Today we're going to take a look at finding volumes of solids when we know what their cross sections look like. Think about what we've done before. To find volume, we've taken the integral of the area. And so if we know the shape of the cross section, then we are going to take the integral of the area of that cross section. A couple of things just to remind you of. Area of a square, of course, is going to be the side squared. Area of a semicircle would be pi over 2 times the radius squared. We'll talk about that one in a little bit more detail later because it's actually easier to kind of go off of the diameter. And then one that you might not remember, and we'll talk about again, equilateral triangles. And that's square root of 3/4 times the side squared. You may have learned that in a geometry type class where you did a lot of area problems, maybe in Math 3, I'm not sure. But if not, that's the equation, and we'll talk about it when we get to it. First example here, consider a region R bounded by y equals x squared, y equals x cubed. A solid has its base in region R. Find the volume of the solid if cross sections taken perpendicular to the x-axis are in the shape of, and then we have some shapes we're going to take a look at. First one is squares. We already talked about that. That's easy. Area of a square is the side squared. Okay. We always want to still be thinking about how we had upper and lower when we were finding area between curves, because the side that's sitting in the region for all of these problems is going to be upper minus lower. The length of that side will always be upper minus lower. So let's think about our region. We have x squared and x cubed. Okay. We've already used this example before. These intersect at 0 and 1. And on this interval from 0 to 1, x squared is actually your upper, x cubed is your lower, okay, because we're dealing with fractions. So let's take a look. If we have squares, we want to find the volume of this solid, so we're going to have to take the integral of the area. So we know our bounds are from 0 to 1. That's where the region is bounded. And we need to take the integral of the area. The area of a square is the side squared. The side is going to be upper minus lower. The length of that side, if it's sitting down in that region, is going to be upper minus lower. Upper is x squared. Lower is x cubed. So we want to square that. The side of the square is x squared minus x cubed, and we want to square that for the area. If we go and take our integral, we have x squared minus x cubed all squared, comma x, comma 0, comma 1. And our volume is very small, 0.0095, which would round to 0.001. Oops, sorry, 0.010. Might help if I could round correctly. Now let's talk about another shape. We have semicircles. Again, think about a semicircle sitting in this region. The base of the semicircle would be the diameter. So you have the diameter sitting in this region. So that length, that upper minus lower, is the diameter. So we want to get our area in terms of the diameter. We know that the area of a semicircle would be pi over 2 times r squared. Well, we know that the radius is the diameter divided by 2, right? So if we take this, square this, we have the diameter squared over 4. So this becomes pi over 8 times the diameter squared. So now we know that we could always write our area in terms of the diameter for a semicircle as pi over 8 times the diameter squared. Okay, so if we try to set that up, pi over 8 times the diameter squared, diameter is upper minus lower. That makes this a lot easier to figure out. Okay, pi over 8 times integral from 0 to 1 of upper minus lower squared. So x squared minus x cubed all squared. Okay, we just got this number. We had this number already. We just need to multiply by pi over 8. That's the same integral we just had. We just need to multiply it by pi over 8. which gives us 0.004. Okay, so there's our volume. Okay. Next, equilateral triangles. Let me change my color. Area of an equilateral triangle is square root of 3/4 times the side squared. I could go through a method showing you how to get that. Basically, you're using 30, 60, 90 triangles because remember an equilateral triangle has all three angles at 60 degrees. But just believe me, it's square root of 3 times the side squared. So if you ever see that one, you want to take square root of 3/4 times the integral of the side squared. And side would be upper minus lower. So x squared minus x cubed again, all squared. So I don't know if this one, will this one go back up? Nope. Okay, so let's take square root of 3 divided by 4 times the integral. That's not the integral. Here we go. Of x squared minus x cubed, all squared, comma x, comma 0, comma 1. And that gives us, did I do that right? Oh, I forgot my x squared. Dang it. Okay, so let's redo that. Maybe. Okay. Square root of 3/4 times the integral of x squared minus x cubed, all squared, comma x, comma 0, comma 1. Now we got it. All right, so that is 0.004. Okay, now let's try last one here. Isosceles right triangles with the hypotenuse as their base. So the first thing we're actually going to need to do is figure out what's that equation. Okay, because let's think about, we've got isosceles right triangles with the hypotenuse as their base. So we have right triangles, these two sides are the same. This is your hypotenuse, which is also your base. Okay, think about this. If we needed the height, because area of any triangle is 1/2 base times height, right? So this is our base. Let's call it B. We know that this side and this side of the right triangle are equal because it's an isosceles right triangle. It's 45, 45, 90 triangle. We could find those by dividing by square root of 2. Okay, so that side is B over the square root of 2. We could take this one and divide it in half because the whole thing is B. So this bottom piece would be B over 2. Think about what we have. We actually didn't even need to divide by square root of 2. I don't even need this because let's think about why. This is a 45, 45, 90 triangle that we've broken this into half. So we have another 45, 45, 90 triangle. If this bottom piece is B over 2, then the height is going to be equal to that. The height is also B over 2. So area for an isosceles right triangle with the hypotenuse as the base, 1/2 times the base times the height, which we just said was the base over 2. That would be 1/4 times the base squared. So now we can always say anytime we see isosceles right triangles with hypotenuse as the base, we know that formula is 1/4 times the base squared. We don't have to draw that every time. We know that's the equation. So if we want to find the volume, we need to take 1/4 times integral from 0 to 1 of the base squared. And base would be sitting in that region, so it would be upper minus lower, x squared minus x cubed, all squared. So let's do that one. 1/4 times the integral of x squared minus x cubed, all squared, comma x, comma 0, comma 1. Wow, that one felt like it went a lot faster. And that gives us 0.002. Okay, so these are very small volumes, okay, but we were dealing with a pretty small region to begin with. Let's take a look at another example, a little bit more complicated. So we're going to look at some trig now. Let's say we have f of x equals 4 cosine of x over 2 and g of x is sine of x. And we're only looking at the interval 0 to pi, which works out nicely because they don't cross each other. A solid has its base in that region. Find the volume of the solid if the cross sections are these shapes. So let's go through. First of all, let's talk about what our region looks like. Okay, 4 cosine of x over 2. Okay, we're going to start and kind of go down here. Sine of x, going to start at 0. These are going to end up meeting at pi, because think about y. Pi over 2, 4 cosine pi over 2 is 0. Sine of pi is 0, so those end up meeting at pi, which is the edge of our region. So we're looking at this region in between. Okay. Now, we want to find volume if the cross sections are in the shape of squares. Notice they're perpendicular to the x-axis, so everything stays in terms of x. Area is the side squared. We already know our bounds, 0 to pi. So volume is going to be the integral from 0 to pi of upper minus lower squared. The side of the square is going to be upper minus lower. Upper is 4 cosine of x over 2. And lower is sine of x. We want this all squared. Okay, let's go find this. Again, make sure that your calculator is in radian mode. Otherwise, you're not going to get the right answer. So let's see what we got. 4 cosine of x over 2 minus sine of x, all squared, comma x, comma 0, comma pi. And that gives us 16.037 for our volume. Notice we're getting some bigger numbers now, so that's nice. We're not dealing with those tiny, tiny decimals. Let's try the next one, semicircles. Area here we said was pi over 8 times the diameter squared. So volume, we want to take pi over 8 times integral from 0 to pi of the diameter squared. Diameter would be upper minus lower. Okay, let's find that value. I wonder if I can store this. I'm going to store this value that we got for this integral because we end up using this quite a bit. So I'm going to store this as, what do I want to call this? Let's store it as the letter A. Okay, anytime I type an A in now, it's going to give me that value. So this is pi over 8 times that integral. So I'm just going to do pi over 8 times that value we had. What are you doing? Alpha A. There we go. All right, and that gives us 6.298. Okay, that's the volume if we have semicircles. Okay, isosceles triangles with hypotenuse as their base. That's supposed to be isosceles right triangles with hypotenuse as the base. So we said that that formula was 1/4 times the base squared. We have 1/4 times integral from 0 to pi of the base squared. Upper minus lower would be 4 cosine x over 2 minus sine of x all squared. So I'm going to take 1/4 and I'm going to multiply by that value that we got for our integral. And that gives us 4.009 for the volume when we have isosceles right triangles with hypotenuse as the base. Now, here's a new one for us. Rectangles with height always 3 times their base. Okay, so we know area of a rectangle is base times height. Well, if the height is always 3 times their base, then we plug in 3 base for the height. That gives us 3 times the base squared. So our volume would be 3 times integral from 0 to pi of the base squared. The base, of course, would be upper minus lower, 4 cosine x over 2 minus sine of x, all squared. So we want to take 3 times that integral that we already found in this case. That gives us 48.111. Okay. So again, you can use, if you're finding multiple of these, most of the time you're only finding one of these. And so usually you're not finding multiple different ones in the same problem. You may be doing different things and typing in different integrals, but usually you're not finding more than one volume of a cross section in a problem. So you would be typing these in separately depending on your different problems. Okay. We could kind of take that shortcut because we had the same integral that we were using for all of these, but that will not always be the case. Make sure that you know your formulas. Some of these you have to figure out. If it's one like this, that last one with the rectangles, you're going to have to figure that out, but it should be easy to write that equation out. Depending on what they tell you, they should give you some indication as to how the height and the base relate to each other, so you could write it. Otherwise, it is good to kind of have those other ones memorized. Isosceles triangles with a hypotenuse as the base, that's 1/4 times the base squared. Semicircles, pi over 8 times the diameter squared. Squares, we should definitely know the side squared. The equilateral triangle, square root of 3 over 4 times the side squared. Guys, I will tell you the most common types are squares and semicircles, which is nice because those are probably the easiest ones to remember. And then after that, it's kind of a toss-up. It's kind of even as far as the different ones. The rectangle type ends up showing up quite a bit because it's not a set formula and you have to kind of figure that out. So I've seen all of them on multiple choice before. I've seen mostly squares and semicircles in free response questions. But again, these are all things that you kind of have to either know or figure out, and you need to make sure that you remember we're taking the integral of the area of the cross section in order to get that volume.